Alright, welcome back to Bad Choices. I really need to make an LPIC video, but instead I'm gonna just do what I like. I'm just gonna have some fun, which is definitely not a good choice. Um, so what I'm gonna do is continue on with the Automate Your Network series. I really can't even read more from the book because and I'll do a mic check. Mic check 1 2. It looks good. So. And I'll do a static check as well. All right, looks. Oh, there is some static. All right, not so bad. Okay, looks good. So, yeah. So, I can't even really read along in the book yet because it's a presupposes a network state that I think is just kind of ridiculous to presuppose. Like, what network doesn't have new devices, plugged into it? Like, to just gloss over that and not say, you need a plan for a new device being hooked up is silly. Like, so kind of, this book can't get a full 10 out of 10. Still pretty high marks, but for not tackling that head on, which in my opinion is kind of the biggest part of the whole thing. To just gloss over the part that really matters, in my opinion, is kind of not cool. So I think it's down to like an 8 out of 10 is the highest score it can get. But the good news is we did have a really good conversation with the AI. We really pinned it down and told it, because it kept doing that same dance with us, where it's like, you know, how do I turn up this device in the network so that there's automation from day zero of the device being on the network? There's automation from second zero, like, zero touch provisioning, like that. How do I get that stuff to work? And uh, so here's a step by step guide on how you can do that with DHCP and dynamic DNS. So the first thing you need is a DHCP server. That gives you, that makes it so what we're doing here manually, we're going through and configuring IP IP addresses. That's off the table. That's just done automatically. So that's good. Then the next thing you can do with having a DHCP server, you can have options for you can yeah. So I'm pretty sure DNS has well, let me see here. But you can have it connect back to a TFT server, and then get a boot file. So you also need a DNS server. Um, so yeah, this is what we're gonna do. We're gonna focus on getting ZTP to work. So so let's go to our lab, and what we can do to do that. I have this extra toolbox machine. All this is a Ubuntu machine that doesn't have the GUI. It just has the command line. So my plan with this is we'll stick this in the data center somewhere like that, and then anything that gets plugged into the network, or actually, yeah, we'll stick it to the data center, and then we'll stick it to the out of band um, switch. So it'll go here, but it'll plug into the out of band, and then our out of band network will be automated from this DHCP server here. And then this will serve as the DNS server as well. So hopefully that makes sense. And even more, hopefully it'll work. Okay, so if I put this here and I'm gonna say I'll call it the ZTP server. So I'll call it the ZTP automation ZTP server. Yeah, okay. I'm okay with calling it that. And we can't do spaces. Can't do underscores either. Day 0 ZTP. Okay, we can call it that day 0 CPT. Now, sometimes there are issues with selecting things, so I might have accidentally named something. Oh no, there we go. Okay, it did change. Perfect. Okay, so now we need to plug this into the out of band switch. Oh, and we're out of ports on that one. We could plug it into any one, but I think where it makes the most sense is in the data center. Let's do it in the core, just because it's more. Then it's like plugged into, you know, like the because we've got just a daisy chained switches here. So if we put it like in the middle of the daisy chain, that might be what makes the most sense. And we've got plenty of ports on the core. Okay, so this is how we're going to go about it. We're going to configure a DHCP server here. We're going to configure a static IP address on here. But the thing is, like, yeah, and then the thing is, you know, DHCP is a broadcast, so we don't have to do anything on a new device as long as it's set up automatically for DHCP to reach out with a broadcast message. So I really think this is the way to go. So yeah, so the first thing we need to do is set up a DHCP server on this device. Okay, so we'll go to ChatGPT and we'll say, and we'll do a new chat for this. Okay, so write me a guide for configuring ZTP for new devices on my network. Yeah.
Zero-touch provisioning, ZTP, automates the process of configuring new devices on network. The following guide provides a step-by-step approach to configuring ZTP for new devices on your network. This guide assumes that you have a basic understanding of networking and have access to the necessary hardware and software. 1. Prerequisites hardware. A ZTP server, a DHCP server, network switches, routers, the devices to be provisioned, network connectivity software. Networking operating system with ZTP support, like Cisco IOS, Juniper Junos, Forest AOS, etc. A DHCP server software, like ISC DHCP, a web server, like Apache, Nginx. 2. DHCP server configuration. On your DHCP server, you need to configure options to point a new device to the ZTP server. Add the following DHCP options. Option 67, boot file name. Provide the file name of a script or configuration file stored on the ZTP server.
Looks good to me.
Option 66, TFTP server name, or option 150. Provide the IP address of the ZTP server. Example configuration for ISC DHCP server. 3. Web server configuration. Install and configure a web server on the ZTP server to host the configuration files and scripts. Install web server. Bash copy code sudo apt-get install Apache 2 hash for Ubuntu. Place your configuration files and scripts in the web server's root directory, typically var www html. 4. Create configuration scripts. Create scripts or configuration files tailored to each device type. These scripts should configure the basic settings such as hostname, management IP, and other initial configurations. Example ZTP config. Shish. 5. Place scripts on ZTP server. Upload the scripts or configuration files to the web server's root directory. Ensure they are accessible via HTTP, HTTPS. 6. Connect new devices. Connect the new devices to the network. Ensure that they are set to factory defaults. 7. Monitor the ZTP process. Monitor the device console or the logs on the ZTP server to ensure that the devices are being provisioned correctly. Verify the configuration on the devices once the ZTP process is complete. 8. Troubleshoot if necessary if a device fails the provision. Check the DHCP server logs to verify that the device is receiving the correct DHCP options. Check the ZTP server logs to identify any issues with the configuration files or scripts. Check the console logs of the device to identify any errors in the ZTP process. 9. Final verification. Once the ZTP process is complete, log into each device to verify the configuration and ensure that the device is operational and reachable on the network. Conclusion. ZTP can greatly simplify the process of adding new devices to your network by automating the initial configuration steps. By setting up a DHCP server to point to a ZTP server and creating configuration scripts or files, you can streamline the deployment of new network devices.
Yeah, but see how like there's just so much assumed. Like, I'm just worried, like, you know, because I've had this kind of experience where it's like, oh, I know everything about network automation. It's like, well, yeah, you know everything written about network automation, but when you get to the job, you don't know anything that's not written about it. So, you know, this presupposes a lot, that we have these switches here hooked up to everything, and that we have a server like this hooked up. So, like, you know, you've got to configure these switches. You got to make sure that the layer 2 connection is good to go. You got to make sure that they're like actual, like, you know, healthy enough switches so that, like, you don't deal with like collisions, stuff like that. So, like, your broadcast domain isn't too big. So, like, but I mean, you should be fine with just a kind of a crummy network like this. The other thing is you got to make sure it's not cabled together in a loop. Otherwise, you're going to cause, you know, broadcast storms, layer 2, unless you set up spanning tree, which hopefully your switches will automatically have spanning tree. And you know what? If they do have spanning tree, then yeah, cable it up in the loop so that if there's an issue, you're fine. But if your switches don't have spanning tree, and it seems like these switches probably do not, I do not see anything about selecting about spanning tree. Do not do that, please. So, you know, we're already presupposing a lot of information, and it's hard not to do that. I mean, honestly, like, if you presuppose nothing and you write a book, it's going to be millions and millions of pages long. So it's just important to know that there's a lot presupposed. So yeah, we've got our ZTP server. So this is going to be where we do all the and we can have it for ZTP, we can have it for DHCP. We've got our network and switches to be provisioned, and we've got network connectivity, and we have a dedicated out of band network as well, using just some cheap switches. All right, so then we have our software, which is we have a network operating system with ZTP support. Yeah, we have that, but not all of them might have that. That's okay. We'll use another method if there's one that's not exactly perfectly optimized for ZTP. All right, then the next thing we need is DHCP server software, so we'll get there, and a web server. So DHCP server configuration. On your DHCP server, you need to configure options to point the new device to the ZTP server. So now it looks like we can do it in Bash. Yeah, let's try it. Let's just keep with the scheme that they have. And actually, let me go back and undo some of the configuration. So I'll just set the interface management 0 IP back to DHCP. Now okay. Now if we were to do it in the real world, or again, the ZTP software from what I understand, we already aborted using that. So we'd have to like reinstall it again, wipe it, reinstall it again. So yeah. Okay. This is a good thing. Alright. Sorry, I've been having lower back issues. Just added the blue and using barefoot shoes, and I think that's what caused it. And like for the first time in a week, I feel like I have some flexibility back. Okay, so here we actually didn't even set it up correctly. I know you might think, oh, well, you're doing the thing that you're trying not to do. You're just configuring it for DHCP instead of a specific address. It's like, well, technically, yeah, in this case, but like, this is just like a temporary measure. Like once we get it working, we'll get it to the point where we can just drag and drop one of these, plug it in, and then it's just all good to go. Okay, so let me see here. Okay, so this is a bash script. I'm not quite sure what to do with this. So this is a ISC DHCP server. So tell me how to install an ISC DHCP server on my Ubuntu machine.
Installing an ISC DHCP server on your Ubuntu machine can be done by following the steps below. The ISC DHCP server is a popular open-source DHCP server that can be installed and configured relatively easily on Ubuntu. Step 1. Update package list before installing any new software. It's always a good practice to update the package list for upgrades and new package installations. Open a terminal and run. Step 2. Install ISC DHCP server. To install the ISC DHCP server, execute the following command in the terminal. Step 3. Configure ISC DHCP server. Add a DHCP configuration file. The main configuration file for the DHCP server is located, etc. DHCP, DHCPD. Conference. You need to edit this file to define your DHCP settings. Bash copy code sudo nano, etc. DHCP, DHCPD. Conference. Here is an example configuration.
Okay, so we need our out of band management network to we need this server to be accessible to the internet. So we don't necessarily need that accessibility to come from the out of band management network, but we do need it. We do need it to come from somewhere. So we could put this in the internet server room, and then that might be a better place for it. So we can put it in the internet service room, plug it into the internet out of band switch, and then also plug it into the internet cloud. So obviously, it's not going to be that easy in the real world. We'd have to plug it in like to this switch, this device. Like you plugging something just into the cloud, especially from, that doesn't make any sense. It doesn't make any sense to have a connection into the cloud. I mean, I guess how we could think of it is like if this were like a Chromebook with like a SIM card and we connected it into like a local tower, and then we could get into the internet like that, and then let's think of it that way. So like this is like a Chromebook that has like a SIM card on it, but I don't know if Chromebooks can have wired connections. I don't know. It gets tricky. I'm probably overcomplicating it as well. I'm never gonna get it done if I make it this complicated. So I'll add a new adapter to it. Oh, and we still only got one adapter. Sometimes it takes a while for it to update. Yeah, there we go. So plug this into the internet OOB. Oh, but the thing is, it doesn't. So I guess we might have to get the network, the out-of-band network internet access, which is kind of scary. Like, I don't think I want the out-of-band to have internet access, but at the same time, like, you have to, because like if you have a remote worker coming into your network over the internet, they need to be able to use the out-of-band. But at the same time, you don't, like, once you have the connection, you can use a device in the network to connect to another device. So it's like they can come in and they can like connect into like this as a jump host, and then the jump host is on the out of band network, which hopefully should never go down, and then they connect into the actual network that way. And then if there's an actual issue, they cut off their legs or whatever. So let's rename this again. We're gonna call it ZTP server / jump host. All right, and then we'll ask the AI. Oh, is it too long? Let's look at the console. Invalid name. Oh, maybe you can't have an underscore. And we'll call this DHCP DNS jump host. Yeah, so we'll call it OOB. Yeah, you can't have an underscore. So let's be very clear about what a jump host is. What is a jump host? Host. What is a jump host?
A.
Yeah.
Jump host, also known as a jump server or bastion host, is a dedicated intermediary server that is used to manage access to other servers or resources in network.
Right.
It acts as a bridge between the public internet and your internal network, providing an additional layer of security and control. Purpose and use of a jump host. Security. Jump hosts are typically hardened and monitored more closely than other systems, making them more secure access points. Access control. Admins use jump hosts to control and monitor access to the internal network, as all SSH traffic, or RDP for Windows environments, must pass through this host. Audit trail. Since all connections are made through the...
Yeah, so actually I think the best place for our jump host is right here. And then we plug it into the firewalls. So I think that's the best place for our jump host. Yeah, so let me plug that in like that. And we can have redundant connections for that as well. Yeah, I think that makes the most sense. All right, I'll be back in a minute. All right, I'm back. Let's keep going. So let me ask you one more thing about jump host. So where would a jump host ideally go in your network? So, sorry, I don't think you have information about my network. I can provide you an Ansible hosts.ini file, a Ansible inventory file for you. I can provide an Ansible inventory file for you to help you understand my network. But generally, where would a jump host go? Would it be connected to the firewalls?
In a typical network architecture,
Yeah.
the jump host is strategically placed in a demilitarized zone, DMZ. The DMZ is a subnet that sits between the internal network and the external network, internet.
Right.
This setup provides an additional layer of security, as the jump host acts as an intermediary between external and internal network traffic. Here's a simplified layout. Key points. Firewall connections. The jump host is usually connected to both the external firewall, facing the internet, and the internal firewall, facing the internal network.
Yeah.
Network segmentation. The jump host resides in its network segment,
like
DMZ,
right here.
isolated from both the internet and the internal network. This helps in containing any potential security breaches. Restricted access. The firewalls are configured to restrict access, allowing only necessary connections to and from the jump host. For example, SSH or RDP traffic may be allowed, while other types of traffic are blocked. Connection to internal resources. Once a user connects to the jump host, they can then initiate connections to internal resources based on the permissions granted to them.
Regarding
Ansible inventory.
Advanced data analysis. Upload this picture here. Okay, and then we're going to save it under like downloads. We'll call it lab network. All right, and then we'll upload it. All right, and then just give it that.
It looks like you've uploaded a file named lab_network. PNG. How can I assist you with this file?
Describe the image contained in this file.
I'm unable to directly see or describe images. However, I can analyze the image using various techniques to gather information about its content. For example, I can compute basic properties of the image like its dimensions, color distribution, and the presence of text. However, please note that my ability to interpret images is limited compared to my text-based capabilities. Would you like me to attempt to analyze this image for specific features or properties? If so, please specify what you're looking for.
Try to try to try to determine whether or not this image is of a GNS3 network topology.
GNS 3, Graphical Network Simulator 3, is a software tool used for network simulation and topology design, often used to visualize and test network configurations. Topology images from GNS3 typically contain network devices such as routers, switches, and firewalls connected by links and might have labels or annotations. To determine whether the image is of a GNS3 network topology, I can look for common features associated with such topologies, such as text annotations. GNS3 network topologies often contain text.
Aha!
It seems like there was an error while trying to analyze the color distribution of the image. The error occurred because the image array couldn't be reshaped for counting unique colors, which could be due to the image having an alpha channel or being in grayscale. Let's first check the shape of the image array to understand its structure and then proceed with the color distribution analysis accordingly. Would that be acceptable?
No! Yeah, it would be acceptable.
The image has a shape of 536 times 977,536 times 977,536 times 977 pixels and contains 4 channels. The presence of the fourth channel suggests that this is likely an RGBA image, where the A represents the alpha transparency channel. To analyze the color distribution, we should consider only the RGB channels. Let's adjust the analysis to exclude the alpha channel and then proceed with finding the unique colors in the image. Shall we?
I don't really care about the colors.
Based on the analysis of the image, here are the findings. Text annotations. No text was detected in the image through optical character recognition, OCR. Shapes and lines. Only one contour was detected in the image. In typical GNS3 network topology images, we would expect to find multiple contours representing various network devices and links. Color distribution. The image has a diverse color distribution with 7,120 unique colors. This suggests that the image is likely complex and detailed, which is consistent with network topology diagrams. While the color distribution indicates complexity, the lack of detected text and the presence of only one contour do not strongly support the hypothesis that this image is a GNS3 network topology. However, it's worth noting that OCR and contour detection are not foolproof and can miss elements depending on image quality, font type, and other factors. Would you like to proceed with any additional analysis or have any specific aspects of the image you would like to explore further?
Yes, it is. Apology. Tell me some facts about this network.
Given that.
I can't see the image.
The image is indeed a GNS3 network topology. Analyzing it could provide insights into the structure and components of the network. However, without the ability to visually interpret the image, extracting detailed information is challenging.
What can I do to have
GNS3 network
you
topology
see
may
the
include various
image?
network devices such as routers, switches, firewalls, and computers connected by links. Annotations like device names, IP addresses, link statuses, and other configuration details are also common. Since OCR didn't detect any text in the initial analysis, I can attempt a more detailed analysis by enhancing image, preprocessing the image to enhance text and shape features, such as applying thresholding or edge detection, which could improve OCR and shape detection results. Zooming in. If the image is large and detailed, zooming in on specific parts may reveal more information through OCR and shape analysis. Would you like me to attempt these additional analyses, or do you have a specific aspect of the network you are interested in? Since I'm not able to visually see images, I rely on various image processing and analysis
so
techniques
how
to
do I help
extract
you with
information.
that?
For a GNS3 network topology image, enhancing the features in the image and performing more detailed analysis can help in extracting more information. Here are the additional analyses I can perform. Enhancing image for OCR. Apply image preprocessing techniques such as adaptive thresholding and morphological operations to enhance the visibility of text in the image, and then perform OCR again. Enhancing image for contour detection. Apply edge detection techniques like canny edge detection to identify shapes and lines in the image, which represent network devices and connections. Zooming in. If the image is large and detailed, analyzing specific regions of the image might reveal more details. Would you like me to proceed with these additional analyses? If so, which one would you like to start with? Alright, let's start with the first analysis. Enhancing the image for OCR.
See,
We will apply adaptive thresholding and morphological operations to enhance the visibility of text in the image, and then
I think I could help it by giving it each of the sections like in a full screen like this. I think I could help it out like that. Now I don't have the ability to move around, unfortunately, so it's a little bit tricky in that regard. Yeah, I can't move around. I can move around like this, but I can't like screenshot everything I want to screenshot. Because I can't go up high enough. Yeah, it'll cut that part off. And like, you know, there's lines through it, so the OCR isn't gonna figure it out anyways. But you can see it like has it like pretty close. So like I can just tell it what like it knows enough about it to probably understand. So like here, so like I know that you can't I know that you can't read the text and you can't see the image very clearly. But what can you tell me about the image, knowing that it's a GNS3 topology of a campus enterprise network?
Information that the image is a GNS3 topology of a campus enterprise network. We can infer several general aspects and characteristics, even though we are unable to extract specific details from the image. Network devices. Campus enterprise networks typically consist of a variety of network devices, including routers, switches, firewalls, access points, and end devices like computers and servers. These devices would likely be represented by different shapes or icons in the topology. Network segmentation. The network is likely segmented into different subnets or VLANs to separate traffic for different departments, user groups, or services.
I mean, that makes
This segmentation
sense.
can be visualized by different colors or areas in the topology.
It's gonna assume that there's a lot of Wi-Fi in it, because like there would be in a campus network. Like it's not gonna know what is a Wi-Fi.
Image is relatively large. We can divide it into smaller regions and analyze each region separately. This approach might help in detecting text and identifying shapes more accurately, as it allows us to focus on smaller details that might be missed when analyzing the entire image. I will systematically divide the image into a grid of smaller regions and perform the following analyses on each region. OCR. Attempt to detect any text in each region. Contour detection. Identify shapes and lines representing network devices and connections.
My name is now Hal for the... Oh wait, would my name be Hal? Who's Hal? Oh, no, I'm Dave.
After systematically analyzing multiple regions of the image, here are the findings. Text detection.
Well,
No text
that's
was detected in
okay.
any of the regions through optical
So
character
what if I
recognition,
told
OCR.
you that...
This suggests that either the text is not recognizable by the OCR
Okay,
tool used,
fine,
or the text is too
but
small
you
or
can
obscure.
see...
Contour detection. A varying number of contours were detected in different regions, with counts ranging from 12 to 126. This indicates the presence of multiple...
Okay, fine, but you don't need to see every detail, right? You know enough about what a campus enterprise network would look like to get a sense of what's going on, right? I mean, yes, it's fair that you wouldn't know where the wireless gear is or like the wireless controller and the access points and all that, but just ask me questions about stuff that you don't know about. I mean, there's no wireless in my network. I don't know how to simulate that in GNS3, so that should simplify that a lot, knowing that there's no wireless components.
Absolutely. Even without specific details from the image, we can discuss general aspects of a campus enterprise network, and I can ask questions to gather more information about your specific network. Knowing that there are no wireless components in your network does simplify the discussion. Here are some questions to understand more about your campus enterprise network.
Yeah.
Hierarchy and layers. Does your network follow the typical hierarchical design with core, distribution, and access layers?
Yes. Okay, so these are good questions. So, yes, it has core, distribution, and access layers. But the data center is self-managed on-prem. So while the core does connect to the distribution layers of while the core does just of the internet, WAN, and floor 1 components of the network, sections of the network, when it connects to the data center, it connects directly to the network spines, which then connect to the leaves. It connects to the enterprise architecture connects to a data center architecture. All right, so number 2, network segmented. It's segmented into it's segmented by network function, data center, core, internet, WAN, floors for people to work on. Okay, and then understanding load balancing. Yes, the cabling is set up for redundancy and load balancing. Layer 3 will extend to the network edge. Therefore, ECMP load balancing will be set up. The configuration won't be applied until after I can figure out how to day zero set up the greenfield deployments using ZTP. I want to automate everything I possibly can, except for using mechanical robots to deliver and wire up the gear. But everything else, including especially, but everything possible and practical to automate, I want to automate. I have a ZTP slash DHCP slash DNS slash jump host already set up. I also have a dedicated management network already set up through a series of daisy chained switches. Okay, there we go. Deployments, yeah, probably don't even have to correct the spelling, but it'll probably help. Okay, so number 4, haven't determined this yet. Haven't determined this yet. My network will be multi-vendor. Please provide some suggestions for this. STP probably won't be necessary since L3 will extend to the edge. The edge. Also, I would like to use something like VSS or stacking that will also negate STB. However, this might not be possible to explore given the limitations in my lab. For the AOB network, I would definitely use STP in the real world, but since these are GNS3 simulated switches, I don't know their STP capacity, so I'm just daisy chaining them together and not having them be in a ring topology as I would if I knew they had STP. All right, external connections. Does the network have connections to external networks? Yes. Yes, it has connections to the internet and to a WAN to other buildings as needed. The internet connection is secured via two FortiGate firewalls. Okay, so addressing, haven't figured this out yet. Right now, I just want to focus on greenfield OOB management network network access to establish ZTP, and then the next step will be to build out the in-band network. This is part of an exercise to learn about network automation via Ansible and Azure DevOps, but that exercise presupposes a network state that I am now working to establish. However, it has been frustrating because it feels like the point of automation is negated since the network state required to establish modern automation is still largely a tedious manual process. So I'm trying to automate that process as well, even though it's not talked about in my training materials. All right, so number 7, security and access control. Yes, I'll have control plane policing and ACLs set up. I'll likely use the modern network development life cycle to do this. after the prerequisite network state for the modern has been established. Yes, I'll have control plane policing and ACL set up. I'll likely use the modern network development lifecycle to do this after my prerequisite network state for the modern has been established. So I'll be doing this over an in-band management network using Ansible and the DevOps and the Azure DevOps server. But that's going to come way later. Right now I'm focusing on the prerequisite OOB and in-band network state required for automation tools to work. I'll be using FortiGate firewalls for my internet DMZ. Again, this is way far in the future. I'm focusing on the here and now. Yes, later I will likely use something like SNMP and or Zabbix.
Thank you for providing such a detailed overview of your network. Based on your description, it's clear that you are building a well-structured, segmented, and modern network with a focus on automation and best practices. Here are some insights, suggestions, and additional questions based on the information you provided. Architecture. Your network combines enterprise and data center architectures, which is a common and effective approach. The direct connection from the core to the network spines in the data center can help in achieving low latency and high throughput communication. Segmentation. Segmenting by network function is a good practice, helping in managing traffic and applying security policies effectively. Redundancy, load balancing, and automation. Extending layer 3 to the edge and using ECMP for load balancing are modern practices that enhance network performance and reliability.
Yes.
Your focus on automation, including ZTP for greenfield deployments, is commendable.
But it's hard.
Automating as much as possible will certainly pay off in the long run in terms of manageability and efficiency. Routing, switching, and STP. For a multi-vendor environment, open and standardized routing protocols like OSPF or BGP are advisable. BGP, in particular, is highly scalable and flexible.
How do you use...
While extending L3 to the edge reduces the need for STP, having a protocol like DSS or stacking for link aggregation and redundancy is beneficial. Even in a simulated environment, exploring these technologies can provide valuable insights. External connections and security. Securing internet connections with FortiGate firewalls is a solid choice, ensuring a robust security posture. Addressing IP services and automation frustration. It's understandable that the initial setup for automation can feel tedious and manual, but the investment in automation will significantly benefit network operations in the long term. Balancing immediate needs with long-term goals is a common challenge in network development. Security, access control, and future plans. Implementing control plane policing and ACLs, along with using modern network development lifecycle practices, will enhance network security. It's good to have a clear vision for the future while focusing on immediate priorities. Monitoring and management. Considering SNMP and Zabbix for future monitoring and management is a good approach.
Yeah, I'll be fine.
Zabbix, in particular,
right now,
offers comprehensive monitoring capabilities. Additional questions and suggestions. Automation. Given your focus on automation, have you considered exploring additional automation tools and frameworks such as Terraform or Norner, which can complement Ansible?
Why?
Multi-vendor strategy. Since you are planning a multi-vendor network, how are you ensuring interoperability and seamless integration between different vendors' devices? Documentation. As you build and automate the network, maintaining comprehensive documentation can be invaluable, especially when dealing with complex configurations and integrations. Feel free to share any additional thoughts, ask for clarifications, or explore specific topics further.
Maybe if my network gets cloud components added later I'll consider Terraform, but why would I need to use Nornir? Why not just use Ansible? Why do I have to use so many different tools? Sounds like a nightmare for working efficiently and not being confused. Alright, so the next one, multiverse. How are you? I mean, I don't know. I don't think this is a real problem. Okay, so the last question is: you build and maintain components, especially with dealing with instructions. Like, did they ask me a question? Yeah, that's what that. Yeah, that's the image I showed you. Yeah, that's the image I showed you. Once I have my OB and in-band network established, I'll be following along with my training materials and be doing documentation that way.
1.
Yeah, what is this for?
Applying BGP in a campus enterprise network, BGP, Border Gateway Protocol, can be applied in several ways, depending on the network scale, complexity, and requirements.
Okay, so
Here are
we'll
some
need
scenarios
it
where
for...
BGP can be beneficial: interconnecting with external networks. BGP is commonly used for connecting to the internet or other external networks, especially when there are multiple connections for redundancy.
We might need it right
It
here.
allows for granular control over routing policies and traffic engineering.
And maybe here.
Data center connectivity. Since your network includes a data center architecture, BGP can be used for connecting the enterprise and data center parts of the network, enabling efficient routing and load balancing between different segments.
Need that as well, probably.
Route aggregation and summarization. BGP supports advanced features like route aggregation and summarization, which can help in managing the routing table size and complexity. Scalability and flexibility. For large-scale networks, BGP offers scalability and flexibility, allowing for the accommodation of future growth and changes. 2. Considering additional automation tools. Terraform. While Terraform is known for provisioning infrastructure and cloud environments, it can also be used to manage on-premises resources, including network devices. It allows you to define infrastructure as code, making it easier to version, share, and collaborate on network configurations. Nornir. Nornir is a Python automation framework that can complement Ansible by providing more flexibility and scalability, especially for large and complex networks. It's particularly powerful for custom tasks and workflows, and it integrates well with other Python libraries and tools. Efficiency and confusion. While using multiple tools can seem overwhelming, each tool has its strengths and weaknesses. The idea is to use the right tool for the right job, and often, a combination of tools can address a broader range of use cases efficiently. However, it's essential to evaluate the specific needs of your network and choose tools that align with your goals and skill set. 3. Multi-vendor strategy. While simulating devices does alleviate many interoperability concerns, especially at the physical layer, there can still be differences in how different vendors implement open protocols like OSPF.
Oh, really?
Testing configurations thoroughly and validating interoperability in your simulated environment will help ensure a smooth multi-vendor integration. 4. Documentation. It's great to hear that you are focusing on documentation. Having visual documentation like the topology image, along with detailed configuration and design documents, will be invaluable for maintaining and troubleshooting the network. Do you have any specific configurations or design aspects in mind for implementing BGP, or would you like more detailed suggestions or examples on how to apply BGP in your network?
Yeah. I mean, I don't. This is getting ahead of the curve anyway.
Sure.
This doesn't
Here are some
matter
detailed
right
suggestions and examples on how you might apply BGP in your campus enterprise network. 1. External connectivity. Scenario. If your network connects to the internet or other external networks, you can use BGP for these connections. Implementation. Configure BGP sessions between your border routers and the ISP routers. Use public as numbers assigned by the ISPs and private as number for your network. Route filtering. Apply route filtering to only advertise your network's IP prefixes to the ISPs and receive only the necessary routes from the ISPs. 2. Data center
now. This
connectivity.
doesn't matter.
Scenario. For connecting the enterprise and data center segments of your network, BGP can be used for efficient routing and load balancing. Implementation. Use BGP between the core routers of the enterprise network and the spine routers of the data center.
Thank you.
Assign private as numbers to each segment.
Thank you.
Load balancing. Use ECMP, equal cost multipath, with BGP to balance traffic across multiple links.
I'll just. Okay, fine. Go ahead. Okay, so so what we need is this out of band management network to work. So we're gonna have a demo. Oh, you know what I wanted to ask it about? I'm focusing on ZTP. So if you look at my diagram again. So if you look at my diagram again, I will tell you that the firewalls are in the rectangle that is second most to the right. The nested rectangle that is the second most to the right. Inside this rectangle is an image of a cloud and 1, 2, 3, 4, 5, 6, 7, 8 devices. 8 additional devices. The 5 devices. So of the 5. So the 5 devices closest to the cloud image are this top to bottom. 2 firewalls, 1 jump host, 2 routers. Tell me, is the jump host in the right place? Post in the optimal place to have a good best practice network design? Or does it have to be somewhere else? Right now it is connected to both. Right now it is wired to both firewalls.
Invest. Practice network design. The placement of the jump host, also known as a bastion host, is crucial for securing access to network devices and managing them effectively. Based on your description, the jump host is positioned between 2 firewalls and connected to 2 routers, and it's in proximity to a cloud symbol, which may represent the internet or an external network. Here are some considerations for the placement of the jump host. 1. Security. The jump host should be placed in a secure segment of the network, ideally in a DMZ, demilitarized zone. This allows it to be accessible from external networks while being isolated from the internal network. Having the jump host between 2 firewalls is a common and secure practice. The first firewall restricts access from the external network to the jump host, and the second firewall restricts access from the jump host to the internal network. 2. Accessibility. The jump host should be accessible to administrators for remote management of network devices. It should have connectivity to all devices that need to be managed, either directly or through routing.
Right.
3. Redundancy. For high availability, the jump host should have redundant connections to the network. Connecting the jump host to 2 firewalls and 2 routers provides redundancy and ensures accessibility even if one of the devices fails. 4. Monitoring and logging. The jump host should be closely monitored and access logs should be maintained. Placing it in a well-defined location in the network topology facilitates monitoring and logging.
I'm doing it right.
5. Zero-touch provisioning, ZTP. For ZTP, the jump host can act as a provisioning server,
I'm
providing
doing it
configurations
right.
and scripts to network devices. It should be
Okay.
positioned to efficiently reach all devices being provisioned.
Okay, I'm doing it right. Everything's good. So this is an Ubuntu jump host. So now tell me what I need to configure on it to set it up for ZTP. Yeah, I'm doing it right. Everything's good.
Setting up in Ubuntu. Jump host for zero-touch provisioning, ZTP, involves configuring several services and components to automate the provisioning of network devices. Here are the key steps and configuration needed. 1. DHCP server. Purpose. The DHCP server assigns IP addresses to network devices and provides them with the location of the provisioning files. Configuration. Bash copy code sudo apt-get install isc DHCP server edit the DHCP configuration file, etc. DHCP, DHCPD. Conference. Bash copy code option domain name example. Com. Option domain name servers NS1. Example. Com. NS2. Example. Com. Default lease time 600. Max lease time 7200. Authoritative. Subnet 192. 168. 1. 0 net.
All right, this looks fine. Let's go with this. So, okay, so the first thing we need to do is get a DHCP server. So this is going to be our jump host. So when we hire somebody to work on the network, to do all this crap that can be done here, that is the easy part. So when we do that, they're gonna be a remote worker, so they're gonna come in to our network here, and then they're gonna be assigned a user account here with like a password that hopefully they will get correct. Now there is I am a little bit concerned about that, because like one thing we could do is put this behind the firewall, and then we can like block their their IP from somewhere, but we have to be careful because we want them, this is our internet, so like we can't just only allow their IPs, because these people here are precious and valuable peons, P number employees, I mean to say. They wouldn't be able to access the internet, which they're going to need to do to browse Facebook and watch YouTube videos. So let's so yeah, this makes sense. So let's just follow along, and we should be fine. Okay, so I need to open a console on this. Got it. And then we need to follow the instructions here. Okay, so the steps are numbered, so we're going to start with step 1, which is installing a DHCP server. Now this is a problem. We can't have it like this. We have to have now we're console in, but we definitely have to have it so that you don't have we have to assign a user account to our workers. So yeah, we have to have it so that you log in here, and then you log in from the DHCP server. And we should have this ZTP stuff separate. Like we can have the out of band ZTP, DHCP, DNS stuff all together, but the jump host we should have separate, because we don't want anyone doing something really dumb on the jump host and just bricking our whole capability to ZTP a device, because then we got to roll out someone on the ground. We do not want this out of band management network to be complicated or at risk in any way. That's the most important thing, is that we have that robust and ready to go. Okay, but here we go. So, oops. Okay, sweet. So we have that already. So now we need to set up the configuration. So let's use vi. Okay, we'll go to we'll search for domain name. Okay, so here's the option. So we got to edit it. We'll change it to techyes.com. Okay, it's being bad. Oh, I can't use the arrow keys. Okay, well, that's fine. I don't have to use the arrow keys. Okay, so this is to go down. At least I thought it was. This is to go down. Okay, yeah. And then this is to go up. This is to go, yeah, left. This is to go right. Okay, so we're going to go down here. We're going to go over here. Then we're going to do here and do append. Delete this. We'll call it. Okay, well, let's just use nano. This is busted. Nano is so much better. Look, it's highlighted too. Nano is better. techyes.com. Okay. Then we need to yeah, so down this subnet, this is a very basic subnet declaration. Understand the network topology. Oh, right, because of the options. Oh, shoot, we gotta make all these decisions. Oh, this is rough. Wow, okay, this is really complicated. So the other thing we need to do is change the provisioning script. So let's look for authoritative. So we should be able to search here somehow. I don't see it. It's a bit easier to search in Vi. I'm thinking it's like here. So we changed it here. Oh, here we go. Authoritative. So this, yeah, this is the official DHCP server for the local area network, which is going to be our out-of-band network. So we need to uncomment that. Yeah, that looks good. Default lease time. Yep, looks good. Update style. I don't know what this means. Authoritative, we definitely want on. And then here's the subnet stuff. So here's a very basic subnet declaration. So yeah, let's make so here's the sublet. Let's do that. Here is the subnet declaration for the tech, yes, campus OB network. Okay, so we do need need that. So okay, so we'll do subnet. And I think I already picked this out. Let's see what we got here. Yeah, so we did 10.0.0.0/16. Net mask. There we go. So do four of these, or let's just do 2. Yeah. Range. Now these are the ones we want to hand out. So let's hand out from 1 to 255, and then we'll save some other like addresses. 254. Okay, and then option broadcast address. Now it's a /16, so it's going to 255, and then option routers 10. Oh, this is probably the default gateway, which we might need at some point. So let's set that to .1. Yeah, and let's set this to 255. Yeah, like that. Okay, that looks good. Can probably change it later. And then the file name. Name of the so we gotta name the provisioning script. We'll call it the tech yes ob ztp .sh. All right, and then close the bracket. And that's interesting. They don't have the. Oh, they do have it right there. Okay, so yep, that looks good to me. Okay, let's clear this up, and then there we go. We're done. We're done setting up the DHCP server. So we should see some traffic maybe coming out of it. Let's sniff this link, and let's see if we get any changes in our traffic. Now we're not asking for a DHCP, so it's kind of like not. Yeah, it's not. And then the thing is, we're not even plugged into. So we got to plug into. Let's plug into a different. So this isn't how the network is ultimately going to be, but this will help us determine if our configurations are correct. Oh shoot! Oh, that's so annoying. It's. Yeah, GNS3 unfortunately has its eccentricities, which can be really annoying. All right, so that looks better. Oh, this has to go back more. Oh, somehow I deleted 2 things. All right. All right, so that looks good. So yeah, let's try to delete what I wanted to delete. So we should see the start capture at the top of the menu. There we go. All right, so now let's plug this into somewhere that makes a bit more sense for now. And we're just doing this to test our configurations. So like, you know, I'm not cheating. Oh shoot, it doesn't use systemctl. So my system doesn't have. So I don't have. I can just put this in.
It appears that you are unable to use sudo and systemctl commands, which are essential for managing services on Ubuntu. This might be due to a couple of reasons. Minimal installation, Your Ubuntu installation might be a minimal version that does not include these tools by default. $path variable. The $path environment variable might not be set correctly, and the system cannot find the sudo and systemcdl binaries. Here are some steps to diagnose and resolve the issue. 1. Check $path variable. Run the command echo $path to view the current $path variable. Ensure that the directories usr, bin, and bin are included in the $path. These directories usually contain the sudo and systemcdl binaries. 2. Locate binaries. Use the which command to locate the sudo and systemcdl binaries. Bash copy code which sudo which systemcdl if the binaries are located in a directory not included in the $path. You can either add that directory to the $path or use the full path to run the commands. 3. Install sudo, if not installed. If sudo is not installed, you can install it using apt-get. Bash copy code apt-get update apt-get install sudo 4. Reboot the system. If you still face issues, try rebooting the system. This can be done using the reboot command. 5. Use service command. If systemcdl is not available, you might still be able to manage services using the service command. Bash copy code service iscdhcp server restart. Please try the above steps and let me know if they help in resolving the issue. If a problem persists, we can explore further troubleshooting options. It appears that you are unable to use sudo and systemcdl commands, which are essential for managing services and
I have to give this internet. I think I took its internet away. And let me reboot it so that it. Okay, these should turn to red, hopefully. Actually, they won't turn to red. Oh, they do turn to red. Okay, it's on this side where they won't turn to red. Okay, so now hopefully got that going. Nope. N-O. Alright, I need a break. I'll be right back. Alright, I'm back, feeling good. So what do we got here? Oh, you know what? We've got a device without any internet access. And that happens with these. It's just like, you know, I'm just dropping a random computer out. So that's another thing too. Is like, you know, what kind of devices are you dropping on your network? Are you dropping I don't even think you can use a Raspberry Pi for. Let me. So there's this really cool place in Austin that I really like called Discount Electronics. So like, you know, this is the kind of thing you would have. Like you would have like a. You'd have like a so like here's so like I'm gonna show real world out of band management network is what we're gonna get right now, and you might get like a power backup. And this is just like a disclaimer. I don't know what I'm talking about. We should see some servers in here. Yeah, workstations and servers. So like, it's like this is what we're doing. Like you need something like pretty cheap. Oh, we didn't want ascending. Yeah, like this looks like perfect. And this is the same amount of ports we've got. I mean, you probably want more ports than that. Like this is like absolutely perfect. Was same price, but the other thing you've got to consider when it comes to like switches that have like so many ports, like sometimes they're just, you know, they overheat because there's a lot more like components in them to run those ports. So you might be tempted to just get the biggest switch you can with the most ports for the money, but sometimes that's just a bad decision because it's going to draw more power, it's going to be noisier, it's going to overheat, it's like too big. So like, even though these are the same price here, and you might think, oh well, I'm getting more bang for my buck by getting 48 ports. Well, each of your ports is only capable of 100 meg, which is pretty darn bad. And bigger is not always better. So I would go with this. We have our switches here. The Artband network have. I think they actually only have. Oh yeah, they have 8 ports. So I would go with this for the out-of-band management network. And then the other thing we need is, so we need one of these for each section of our network. So we need, like, in our network here, we need 1, 2, 3, 4, 5 of them. So there we go. We can add this to the cart. I'm not gonna buy it, but oh well. Here's therein lies the problem as well. We need to. They don't have that many. Yeah, and now good luck getting it at that price anywhere else. Discount Electronics is pretty awesome. But you could find something. You don't need. It's just your management network. So like this looks great. This is like perfect. This is better. It's more expensive, but I'd probably go with this instead. Oh, you've only got one 10 gig link, but a 10 gig link for like that's the one you use to like daisy chain them together. I would probably go with this. So you get 5 of them. You can even get like a 5 port. Like I don't know, when you're saving like $10, but yeah. So you could even go with like, because here like we've only got 5 of them. So like you could buy a 5 port for each of your floors, and then yeah. So this is probably what I would go with. And then so here's a thin client. I'm not sure what a thin client is. Oh, it's for cloud computing. I mean, like, yeah, like, this is what we need. But yeah, like you would do something like this. Would be your server. I mean, we could just type in like ZTP server. Yeah, I mean, you just need, like, this would be like perfect, but even this is like overkill. You just need like a basic machine. So like this is a thin client. I'm not sure what that is, but we just need like a refurbished computer. It'd be nice if we could get like a Linux computer, because then we don't need to. So like a no operating system PC, and then put a Linux on it. I don't know how to select. This site seems kind of hard to use. Oh, like a mini PC would be great as well. Yeah, like one of these would be absolutely great. I actually already have one of these, and it works totally fine. It's going to be a leggy piece of crap, and then you don't know, like you need to run like some somewhat sophisticated stuff on it. But like this looks pretty good. You just need to connect it into the network. So we do need a network port on it. So this actually looks like kind of perfect, because we have yeah, it's fanless, which would be nice. This did we have do we have a network port on this one? Yeah, we've got 2 network ports on this one. So yeah, this is probably what I would do in the real world. Um. Oh man, I like this. I might need to to get this. Yeah, lots of ports and stuff. You could get something like this as well. Uh, 200, and you can customize this. But like, I will probably do something like this. So you get in the real world, you'd buy how many? Like 5 of them. 1, 2, 3, 4, 5. Yeah. So there's probably aren't 5 in stock as well, but you can get a combination. It doesn't matter. So like 5 of these is a lot of money. You know, $500 or so. Then one of these. So like this is what we're looking at in the real world. I'd like to try to keep everything clear in the real world. So we'll have this, which will be like where our workers work from. It'll just be a basic like Ubuntu machine. It'll be serving up DHCP, serving up. Well, actually, we might get 2 of these. We might get one that we put like off in our data center or somewhere that like serves up the out of band, so it like connects into the out of band network, and then it just serves up like our ZTP stuff. And then we have another one that our people work off of from. For that one, you probably wouldn't want something like this. You probably would want a big beefy machine, because like if they're running you know, if they're running their automation or like whatever from that, like a big beefy machine, especially if you have like multiple users on it. You know, like you gotta let people do their work efficiently and on time. So if they're all just, you know, having to wait 100 hours just to do a basic thing, that's a problem. But just for your DHCP, ZTP, this will probably fine. It's probably not enough for actually giving people access to the network. But yeah, okay. So hopefully that makes sense. So we're gonna need at least these 2, 2 of these, I'd say, and then 5 of these, and then we do probably want to consider. Do we want them to have yeah, like and the thing is, you know, this is designed for computing that doesn't quit. So like this is a great choice for the DHCP server. So we definitely want one of these. It's just a matter of, you know, and then we have the USB ports will be pretty nice too, because we could like have files in there. That would be like kind of nice to have. Yeah. So so here we go. This is my final answer for that. I think you might want something more beefy. So like especially something like without an operating system that you could just pin up your own on. So like these probably aren't going to be beefy enough. So we'll start with these are the only options we have. I mean, the thing is, like, these are just base. Yeah, so you load it up. So we just load the heck out of it. That'll probably be fine. Yeah, we don't need any kind of display adapters. We don't need any kind of wireless, any kind of speakers. So, like, yeah, something like this would be perfect. It's like, $400. So, yeah, I think this is what we need. So we need this to serve up our ZTP, all that. That'll go off on our data center. We need these to just connect to all our devices. This is fine. We can just get multiple of them. We need at least 5. If we need an extra one, we need an extra one. That's fine. And then we need something like this for our workers to come in and use as a jump host and do with what they will. So we need it to be a bit beefier than this one, so that they're not uh, you know, they're not dealing with a lot of lag. So we should have the other thing we need on this is we need uh so this might not be good actually because we don't oh, we have an Ethernet port here. Which should be fine. But we might need more. We might need better than just that. And we don't have to worry as much about a small form factor, I think. So, if we could get more Ethernet ports, I'd probably take it. So all of these only have one Ethernet port, which would mean like no redundancy. So you know what? I guess I would want that. So let me keep looking at this a little bit, and you can use a laptop. That's fine. So like a business laptop might work. But the thing with a laptop is like the cooling's not going to be as good. It's not going to be as beefy. You don't need a screen, so you're just kind of wasting money on the screen. So I think a desktop would be better. Yeah, workstation or server. Oh, here we go. Yeah, this is now we're on track. I don't think we need video. We don't really need a video card. We just need like network ports. We just need more than one network port for like the redundant connections up to the firewall. I mean, we could have like a extra Wi-Fi to be our redundant connection or whatever. Okay, but anyway, you get the idea. Really, not that complicated. Let's do a search for jump host. Okay, so we don't have anything for that. Let's do a search for Bastion server. Okay, nothing for that. Let's do jump hosts like that. No. Nothing like that either. So let's do like network server. Now this probably isn't even the best place to do this. Doesn't this have two? Yeah, this has two. So yeah, that's my final answer. I'm sticking to it. Two of these, one for dedicated to ZTP, the other one dedicated to having workers use as a jump host. And remember, this is just the out of band management network too. So like they're not gonna necessarily work from this on the in band. They can go directly from their home PCs for that. That should be fine. And then yeah, we do need these. So hopefully that makes sense. Now I'm gonna move on. Okay, so oh, right. Okay, so I need internet. Yeah. Okay, so this I don't think is gonna work. Let's drop a Ubuntu device. Okay, and then we'll uh, copy that, delete this, rename this. All right, and then put this. Yeah, that's got 3 of them. Good. So put this into the internet. Boot it up. And let's change this and let's have this just be like that. And then let's get another one right away to be the jump host. Okay, so now the jump host will have be up like this. Okay, and then the OOB, ZTP, DHCP, DNS. We are going to have be to the internet for now, just because we need to set it up. And then we'll have it be in the core OOB for now. That's probably a good place for it. And we can even like extend this down like that, and like move it in there. Yeah, I kind of like that for now. So let's do that. This is in the core OB. Okay, so we'll start this. Okay, so now we can follow along with the instructions given by ChatGPT. Oh my god, wow. Wow. Oh my god. Sorry, I have this like addiction, and this is way off topic, I apologize, where I like spend a lot of money on like takeout and delivery and restaurants all over town. And I'm fat. So it's like, why am I doing that? Just cook at home. So it's like, I try to convince myself that like I'm just not a good cook and I do it because the food's so tasty. But it's like, I'm a damn good cook. This is better than anything I've ordered out. Like that, I'm in a definitely a foodie town. So like, I can get like New York style pizza that's like really really good. And like, it's a barbecue town. I'm not a big meat guy, but like I can get food that's like worth it once in a while. But I can cook. Like, wow, this is good. Okay. So like, the majority of my destructive decisions when it comes to eating out too much are not as good as what I just cooked. Alright, so remove from favorites. There we go. Don't need any of these. We can add this one to favorites. Yep. We'll keep the files. Okay, so let's test internet connectivity. Network is unreachable. Okay, so not sure what's going on there. We'll try deleting the cable and then re-adding it. All right. Maybe it's just taking a while. That looks like a problem. Yeah, so I guess it wasn't so much of a problem as... Oh, you know what? Maybe it's just taking forever. It says that it's connected. Oh, it says that it's connecting. Alright, not sure what's going on. Definitely need a connection here. Okay, yeah, so I'm not sure what's going on. I'm kind of not doing a lot of interesting things right now, so I think I'm going to end the video here. Try to get this going in between videos, I think, because all I got to do is follow these instructions. So once I get this up, it should be fine. It's clear what I have to do. I'm just not able to do it yet. So yeah, and this video is going on forever. So what are we at? Almost 2 hours. So yep, I think I'm gonna stop it here and try to get some of this done behind the scenes. Because what I want to do, which will be really cool, is like off this WAN or like extend this to do another floor. Just drop all these icons, hit play, and it's just all ready to go. We don't have to do a single thing, and I can do that if I if I give it another connection to the if I give it a connection to the OOB network and put it all in the management interfaces, and then I have this set up. You know, that's not going to be hard, and I've been wanting to do this for years. Like, I just got to get all this stuff to work. So, yep, that's what I'm working on now. Just need basic connectivity. Can't get it. So, I'll work on that kind of between videos. But, yeah, for now, I think that's it. So, thanks for watching and see you in the next one.